Well, hello everyone, and welcome to another episode of Math with Audrey. We still need a name, people. But I'm just gonna stick with Math with Audrey for the time being. So, tonight we're gonna actually take a little venture into radicals. No, radicals, as some people, as laymeans, I would say, will call it square roots. Okay? So, square roots, there's different types. There's square roots, there's cube roots, there are fourth roots, fifth roots. You put a number at the index, and that root will change to that number. So, but we're going to focus on square roots and how to break those lovely things down. All right? So, get your paper ready. Let's get it going. But here is a phrasing that I definitely want you to understand. So when you are combining radicals, okay? So right now tonight we're going to do adding, subtracting, and see if we have time to do multiplying. So when you're adding or subtracting a radical, remember, you can combine, well, especially for multiplication, you can combine radical with radical, okay? And whole numbers with whole numbers. You cannot add, subtract, or multiply a whole number, or even divide a whole number with a radical. They are two separate worlds, okay? So one is a rational number, one is an irrational number. So they just can't blend together, even though they are real numbers, but they just can't bind. So let's take a look at our first example. So we have 2 times the square root of 2 plus the square root of 2. Now, I know for a fact, someone's going to tell me, oh, it's 2 square root of 4, and the square root of 4 is 2, and 2 times 2 is 4, so your answer should be 4. Now, we have a square root being added to a square root. What's in front is always assumed to be a 1. Oops. Okay, it's always assumed to be a 1. So when you're adding or when you're subtracting, you're basically combining the coefficients, right? The radicals are being used just to tell you that you can match those two up. So 2 plus 1, that'll give me 3. And the square root of 7, square root of 2 just comes on down. So my answer is just going to be 3, the square root of 2. Okay, that's it. Okay, so when you're adding and subtracting radicals, you're not doing anything with the radicals. It's almost like if I said that this was 2x plus x. Well, there's assumed that there's going to be a 1 in front of that x. So 2x plus 1x gives me 3x. I don't combine the x's. The x's are just to help me to say which are going to be my like terms. Okay? Same thing is happening with the square roots or the radicals. So all you're doing is matching up the radicals and you're combining what's in front, the coefficients. All right? Welcome in, guys. Thank you so much for being here. All right, so now let's take a look at the next one. We have 3 square root of 6 minus 4 square root of 6. Okay? Now, we have the same radicals. So just like the last one, we're only using the radicals to help find my like terms. So that means we're keeping that square root of 6. But what is 3 minus 4? Okay, so 3 minus 4 will give me a negative 1, but we don't necessarily have to put the 1. Yes, Sin, thank you. Cyan, thank you. So it's going to be a negative square root of 6. Okay, that's it. So when you're adding and subtracting, you're only combining the ones that have the same radicals. So let me change it up a bit so you'll actually kind of see what I'm talking about. So let me slide over here. So let's say we have negative 2 square root of 3 plus 3 square root of 27. Okay, thanks for a follow. Thanks for coming in, guys. So, right away, I won't be able to combine the negative 2 and the 3. The reason why, one, the radicals aren't the same. But hopefully you guys are gravitating to the square root of 27. With the square root of 27, it kind of reminds us what we did last time. We can break this down into a perfect prime combination. So, if you're not sure, let's go to our multiplication chart. Let's go to our factor sheet. So we have our 27. So factors of 27 is 1 and 27, as well as 3 and 9. 3 and 9 is highlighted because this is giving me my perfect prime combination. So I know I can get the square root of 9. The square root of 9 gives me 3, because 3 times 3 gives me 9. Okay? So that means we can break down this square root of 27. And we're going to break it down as the square root of 9 and square root of 3. Because square root of 3, that's a prime number, so we can't do anything with it. So let me bring everything down. Okay? So now we have this square root of 9. And we already said that the square root of 9 is going to give me a 3. But there was a whole number of 3 already in front of that square root. So what you're actually going to do with this is multiply it with the whole number of 3 that we got out of the square root of 9. So that means this square root of 3 is coming on down. And this negative 2 square root of 3, that's coming down. Okay? So what's happening right here is we can multiply those two together. The reason why, they're both whole numbers. So 3 times 3 gives me 9. Then I bring down its square root of 3. Then I bring down the negative 2 square root of 3. Okay? I know it seems like it's a very long process, but the reason why I'm doing this is not everybody knows how to break down radicals. So I really want to show it step by step, and then I can show you how you can shorten it. Okay? So I know. A lot of you are like, why is she taking so long? Because everyone doesn't learn the same. Everyone has been exposed, not everyone has been exposed to the same math. So this is why we like to take it step by step. If I'm going way too slow for you, hey, I love you, but I do not want to take any time away from you. Okay? All right? So now take a look. We have negative 2 square root of 3 plus 9 square root of 3. Now they have the same exact radical. So that's telling me that I can combine this 9 and this negative 2, which will give me my 7 square root of 3. This is my final answer. All right? All right, Lynette, how are you? Okay, negative 2 square root of 3 stays the same. Yes, it does. Yes, it does, until we started combining them because they both had the same square root of 3. Okay. Oh, wow. Okay. Yes. So what are we doing tonight? Tonight we are adding, subtracting, and possibly multiplying radicals. Okay, really focusing on the square roots for right now. Okay. All right. So all we're doing is breaking it down until we can combine it. So let's try another one. So we have negative square root of 12 plus 3 the square root of 3. Okay. Where did the 7 come from in the last one? Negative 2 plus 9. Okay, when the signs are different, you're subtracting. You're welcome. All right, awesome. Okay. And Trish. All right. So Trish is saying we got the square root of 12. So we got negative square root of 12 plus 3 square root of 3. So this square root of 12 can be broken down. And Trish was saying we're going to keep the negative on the outside. She's saying it's going to be 4 and 3. Okay. Square root of 4, square root of 3. Good. Okay. Nice. Thank you for sharing. All right. So, factors of 12. Going right back to my handy dandy. So here we are. We have 1 and 12, 2 and 6, 3 and 4. Okay? So right now, the best perfect prime combination will be the 3 and the 4. Because the square root of 4 is a perfect square root. 6 isn't. I still have to break it down, but then I'll have the 2 2's. So that's like an extra step. Try to shoot for that perfect prime combination. All right? So when I come here, that square root of 4, that's now turning into a 2. But since there was a negative in front, it's actually going to be a negative 2. And then since the square root of 3 is prime, if I can't break it down, I simply bring it down. As well as everything else on the other side. That plus 3 square root of 3. Okay. I tried to be. Trying to be calming. All right. Good. So now we have negative 2 square root of 3 plus 3 square root of 3. Since we have the same radicals, that means we're combining the coefficients. All right? What would I get when I combine the coefficients? What do you think? Okay, so I got my 1s. Good. 1s, 1s, 1s. 1s with the question mark. Get rid of that question mark. You know the answer is 1, Tara. Okay. So we have a 1. But 1 square root of 3 is exactly the same as saying square root of 3. The 1 is assumed to be in front. So this is your answer. Okay. All right. Questions on this? Seems pretty straightforward, right? You know, working it out a little bit. All right. So go ahead and tap away. If you do have questions, go ahead and put it in the comments. For those that are just coming in, my name is Audrey Codner, and I'm the owner of ACG Math Tutoring. I've been teaching mathematics for over 22 years. And prior to teaching, I used to hate math. Yeah, I was part of that hater club. Hated it. Couldn't do it. Didn't understand it. Didn't know why. Why am I doing this? Why am I doing that? I just did not get it until I basically fell in love and I wanted to become a teacher. And then, hey, if you got to teach it, you got to know it. And that just kind of kick-started me to get my insecurities under wraps and start taking a look at what math truly was. It is its own language. Okay. And I'm going to throw another, but the other example I'm going to put, it's going to be subtraction, because I noticed I haven't done anything with subtraction yet. So we'll have 2. All right. So if you want to go ahead and jump ahead and give this a try, go ahead and give it a try. All right, so how do you know if a number is a perfect square? Odd question. So perfect squares, let me slide this over. So a number multiplied by itself, okay? 1 times 1 gives me 1. 2 squared, 2 times 2 gives me 4. 3 squared, 3 times 3 gives me 9. So basically, a number multiplied by itself is considered a perfect square. But if I wanted to get back to the original answer, these answers here, that 1, that 4, that 9, that 16, if I did the square root of those, it will give me my 4, my 3, my 2, and my 1. Okay, so the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Okay, so a number multiplied to itself is considered a perfect square. Lucas, what is your question there? I see your answer. What's your question? All right. When you get a square root, isn't there both a positive and negative answer? Yes, there is. Yes, there is. But right now, when you're doing evaluations like this, they don't want the negative side. Okay? When you are solving an equation, they want you to have both the positive and negative answer. The reason why, because if you started, I'm going to put this off to the side. I know, I keep moving things. Okay, so if I started off with, like, say, x squared is equal to 16, I'm saying that there is 2 solutions because of that exponent. Whereas these are not giving me an exponent. We're just given a root. So we're just looking at the positive values of our answers. But if we are solving it, like say if I come here and then I do the square root of both sides, square root method, because squares and square roots cancel each other out, you have to give me 2 solutions. Because I'm telling you from the very beginning, I'm going to have 2 solutions. Okay, so this will be my plus minus 4. So if you're solving and we're starting with the second degree or second exponent or squared, you have to give me a plus and minus. If it's a word problem and they're saying find the length of the side and you got plus and minus 4, doesn't make sense to have a negative length of a side of a building. No. Right. Okay. Not a problem. But that was a good question, because that tells me that you're thinking. Love it. All right. So now back to this situation. We don't have the same radicals. So we can't just say, oh, doesn't work. No. Take a look to see if we can break any of the radicals down, which this first one we can break down. And I think I saw somebody said it earlier. 1 second. I like to give credit when credit's due. For some reason, why did I think it was Trish? Maybe it wasn't Trish. Okay, maybe I'm losing my mind. There we go. All right. Okay, Nicole, thank you. So we got 4 and 2. Okay, 2 is your prime number, 4 is your perfect. And then there is this 3 that's being multiplied by that, or to that square root of 8. So it's coming down along for the ride. But the square root of 4, that gives me a whole number of 2. So this is the part that a lot of people forget. Don't forget to multiply these two together. And don't forget to bring down that square root of 2. So now, 3 times 2 gives us 6 square root of 2. And then the other side of the expression, we're going to bring it on down. So that'll be plus 3 square root of 2. Okay. So now, and I see a couple of answers. Yes. Oh my God, it's Aiden. Aiden, where have you been? You're like, Audrey, I have a life. I was like, well, nice to see you again, right? Yes. So now that we have the same radical, all we're doing is combining the coefficients. So 6 plus 3, that gives me 9. And I bring down the radical 2. That is my answer. Okay. All right. Eventually, you're going to get quicker with identifying the square root of 8. But that does not have to happen tomorrow. Okay? So if you do need to walk yourselves through the steps and break it down step by step, do so. If you're thinking about taking your GED, Accuplacer, ASVAT, maybe you're taking an intermediate math course and they have you breaking stuff down and you're taking a test. So here's my suggestion. Break down the first one, get your answer, and then take a look at your answer choices. If I see a -2 and I know I'm adding, yeah, that's not my answer. If I see a negative anything, yeah, that's not going to be my answer. So you're doing the process of elimination when it comes to any of those tests, okay? So sometimes you do have to take it all the way down to the bottom to find your answer, but sometimes you can probably catch it. Like, oh, there's 6 and 3. They don't care what's on your piece of paper. They don't care what's on your scrap paper. They only care about what you bubble in, if it's a bubble situation, or what you click. Okay? All right. Okay. Yes. Don't forget to multiply. All right. And this will be our, I don't want to say our last subtraction because I think we're getting this. So I'm going to leave you be. Okay, so this is what I'd like for you to do. Go ahead and solve it, but do not put your answer in until I tell you to. Okay, you can type it in, but don't hit send. All right, give this a try. 2 radical 6 minus 2 radical 24. Okay, try to solve it, but don't put it up just yet. Like about 40 seconds, and then we'll put up our answers. All right. Go ahead and put your answers in. You're allowed to put your answers in. Be confident in your answer. No question marks at the end. All right. Thank you, Ben. Thank you, Salt. Good. Travis. Thank you. And remember, I should say this. Question marks, if you don't know the answer at all, you're allowed to do that. You're allowed for a question mark. But like if you write your answer and then put a question mark at the end of it, drop the question mark. Come on. It's not Squid Games. You're not going to die. All right? Okay. So Auburn Flair, thank you. Is it Oprah? We got Link. Okay, Brandon. Hi, Sandra. You're back. All right. You got -2, square root of 6. Okay, I'm lost to all of this, but it's fun to watch. All right, not a problem. God, I appreciate you wanting to watch. Okay. All right, so I'm seeing some really good answers, but I got a couple interesting solutions. So let's break it down. First thing, square roots are not exactly the same. So I can't go, thank you, a nerd. I can't go right into it, but I can break down this square root of 24. So I go to my 24s. Here's 24. Now 24, the factors of 24 is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 4 and 6 is in red because 4 and 6 is that perfect, which is the 4, and 6. You're saying, well, Audrey, 6 isn't prime. True, but 6 is one of those special radicals that will give you a result of nothing but prime numbers. Let's take a look. So, side note, I'll even put it in orange. So if I did the square root of 24 and I did 4 and 6 and I got my 4, which gives me a 2, perfectly fine, but tried to break down the square root of 6, I'm going to have 2 and 3. 2 and 3 are both prime numbers. Okay, just in case for future tense, the 2 is your very first prime number. I know everyone always thinks it's 1. It's not 1. Okay, your first prime number of the whole list is 2. And what is a prime number? A number multiplied by itself and 1 will give you that result. So the only way I can get a 2 through multiplication is 1 times 2. Think about it. I know, mind blown, right? And the only way I can get a 3 through multiplication is 1 times 3. Yeah, don't even try with the whole fraction. I know you're thinking. Not worried about the fractions, whole numbers, all right? Hey, MJG, how are you? Nice to see you again. Hey, Leanne. All right, would this say solve or factor? This would say simplify. I know, right? I just went to another whole thing. But when it does say simplify, that's exactly what you're doing. You're just breaking it down. Okay, breaking it down. It's almost like a funnel. It's nice and wide. Now you're going to get it down to like a number or an expression. So, like we said, the 24, we don't want to leave our answer with 2 radicals. That's just no, all right? Leave it with the square root of 6, okay? Other numbers or other square roots that does that, besides 6, we got square root of 10 does that. Square root of, not 12, 15 does that. Square root of 21 does that. Okay, these are the most popular ones. Oh, and the other one that's most popular is the square root of 35. Okay, because if I try to break any of those down, I'm going to get a 2. Well, this one will be 2 and 3. This one will be 2 and 5. 3 and 5. 3 and 7. Okay, 7 and 5. all of those are going to be prime numbers. So those are like those special radicals. All right, so you don't have to kill your brain when you're trying to do all this. All right, so now we have 2 square root of 6 minus 2 times, and we already figured out the 24, which will give me 2 times the square root of 6. All right. Now, we can combine these two because they're both whole numbers. All right. 2 times 2, that'll give me 4. Bring down my square root of 6. All right. Minus. Then I have my 2 square root of 6. Now, we have the same exact radicals. Okay, they're both square roots. They both have a radicand with a 6. The radicand is what the number is underneath the square root. It actually has a name, right? So now all we have to do is combine the 2 minus the 4. With the 2 minus 4, like everyone's saying, was negative 2 square root of 6. So we do not have to combine the square root of 6's. They're just there to help us find our like terms. And that's for when you're subtracting or adding radicals. Okay? Come with me with questions. Pour them on in. Good job, MJG. Appreciate you. Okay, thank you for sharing the lives, guys. I'm serious. If you know someone that is having trouble with this, they're probably currently in a class. I know some people are working on this because some of my clients was having trouble with this earlier today. Okay, if you know anybody that's going to take the acuplacer and math is just not their thing, hey, bring it on. Yes, Emerald. Your FYP knows you well. All right. So that is adding and subtracting. Would you like another one? Another example of adding and subtracting. Okay. Taking the ASVAB. Yes. Good. You're breaking the large number down. T. Okay, so I'm saying yes, I'm saying please, I'm saying yes, please, I'm saying yes, please. Thank you, people, for the politeness. Okay. Am I breaking down the larger one? It seems like I am, yes. But sometimes it may be the smaller one that might need a little breakdown, but majority of the time it would be the larger one, T South. Okay? As long as you are. All right, Henny. Okay, let's do another one. Let's see. Let's do something. Get you a little bit challenged, but nothing too crazy. Okay, doing the same process. Do not let the numbers throw you off. Okay. I don't know why it's me and the square root of 6. I don't know. I don't know why it is, but I am. I'm here for it. Okay, so 2 square root of 6 plus 3 square root of 54. Okay. Oh, thank you. Yes, if you do have a moment, chat, tap away. But give it a try. Okay, give it a try. Hold your answers for a moment. Just hold it. Just hold your answers for a moment. Okay, take a quick look. So I just want to give everybody an opportunity to Okay, we're going to show our answers in about 20 seconds. All right, show your answers. What did you get? So Travis had 11 square root 6. Oops, hold on. Okay, MGJ was saying 54 breaks down into 9 and 6. So got 11 square root 6. I have a 10 square root of 15. Okay, I got 10 square root of 15 a couple times. Oh, same person. All right, any other answers? It's okay. You can put question marks. Question marks is the answer as well. Okay, I want you guys to participate. Okay, you're just like, yeah, lady, I don't get it. And this is how I break things down. Okay. All right. Well, thank you so much for the goat. I appreciate that. All right. So we got 5 square root of 6. Okay. All right. So let's take a gander. Okay. So T-South, here we go. We got our larger one, which was the 54. Okay. So we got the square root of 54. So I'll go to my handy dandy. So let's see what we got for 54. So for 54, we have 1 and 54, 2 and 27, 3 and 18, 6 and 9. So 6 and 9, that will be that perfect prime combination because 9 was perfect and 6 will be one of those special prime radicals. So going back, so we got here, we have our 3, and we're going to break down this into 9 and square root of 6. The reason why I like to put the perfect in front is because it's an easy transition when I need to multiply to that 3. So now I put my plus sign. I got my 2 square root of 6. So now we know that the square root of 9, that's perfect. So that's going to give me a 3. I'm bringing down my square root of 6 over here. And we are going to multiply these two 3's together. So now we have 2 square root of 6. So now we just have to put it a little bit more together. So we have our 2 square root of 6 that comes down here. Plus, we have our 3 times 3, which gives us 9. And bring down that square root of 6. So now, we're taking it a step further. We have the same radicals. We're adding. So that means we're taking that 2 plus that 9 gives me 11. I have a habit of like giving the answer away sometimes. Gotta work on that. A little late. I've been, teaching for 22 blessed years. But here we go. Okay? All right. Yeah, Sean, I tried to make it easy. All right, so we got 3, good. We got 9 square root of 6, good. 3 times 3, good. That gives you 9. What's that 2, 6? Oh, okay. Yes, and then we have 11 square root of 6. Good. You were way off? Okay. But did you see, LaCole, where did you see where you kind of messed up? Because I have a feeling you were like kind of subtracting, I think. All right. Okay. Good. All right, now, can you explain how you got the other red 3? The other red 3. Okay. So when I broke down the square root of 9 to square root of 6, square root of 9 is a perfect square root because 3 times 3 gives me 9. But there was already a 3 that was in front of that square root of 54. So this means 3 times. If I don't see a plus or a minus in between numbers or variables, that means you're multiplying. So if I have 3 times the square root of 54, it's coming down. So this is actually 3 times square root of 9 times the square root of 6. Square root of 9 gave me 3. This 3 comes down. So now 3 times 3 gives me 9. And then I can combine these two because they have the same square root of 6. So 9 plus 2 gives me 11. Did I answer your question? Who was that? Brooks? You see it now, Brooks? Okay, forgot to multiply the 3. I get confused with multiplication. It's okay. Breathe onto it. Be all right. We'll just take it step by step. Why 6 can't be 2 times 3? Because the reason why the reason why we don't want the square root of 6 to be the square root of 2, the square root of 3, we don't want our answers to have multiple roots in it. Because then we wouldn't be able to combine these two. You don't want your answer to be like 11 square root of 2 square root of 3. It looks unfinished. Just leave it as 1. Okay. Why do I have to do another one, T-South? He's like, you have to do another one. Why do I have to? I figured it out and I don't know how to do square roots. Good. I try. I get confused here and multiply the wrong numbers. All right. Why? Okay, so we got that. We got that. She's perfect square roots. Okay, come on. I'm going to be here till like 2 o'clock in the morning. I'm just teasing. All right, let's see what we got here. You know what? I'm going to do a little combination. You're like, oh no, we ain't saying to make it harder. We just said we just need another example. All right, so let's try this. We have 2, square root of 2 plus the square root of 5, okay, minus 6, the square root of 2. Ooh, okay. Take a moment. The square root of 2. Ooh, okay. Take a moment. Sorry about that. I love when people want to call me. What are you calling me for? Like, you know? You know what time it is? Like, I'm not going to answer the phone. All right, I'm here. Do you guys see me? Or am I losing my mind? All right. Are we back? Everyone's back? Okay. All right. Okay. All right. Yes. All right. Yay. Okay. This is a good refresher. I'm taking the T's. Oh, yes. That's another good thing. Especially the algebra piece. In a couple weeks. Nice. Okay. Yeah, I'm still here. Someone was trying to call me. I don't know why. Now, don't freak out. Take a look. What can we combine? What can we combine? What can we combine? I have a feeling, Nicole, you're going to be okay. Okay? So, what are the like terms? Is it jazz? Okay, so MJG says the 2 and the negative 6. Okay, Nicole says 2 and the negative 6. Good. All right, the ones with the same radicals. Exactly. Hey, Pop. All right, so combine these two. What do you get when you combine them? What do you get when you combine them? So I got a couple people with -4. I got a -4 square root of 2. I know it's hard to do the square roots. -4 square root of 2. You got square root of 2. Yes. Good. Good. Hey, Cookie. Good. He's over here telling me you probably got wrong answers. All right. So we got our square -4 radical 2. And I'm going to bring down my plus square root or radical 5. Can I combine these? Yes or no? Y for yes, N for no. No. Nope. No. No. Good. And the reason why, good. Good. I love people out. Yes, Missy, good. All right. Yes. Drake. Good. Allison. Awesome. This is awesome. Good. All right. So we cannot combine these two because they're not the same radical. Yeah, they're both square roots. Okay, that's cute. But the radican, which is underneath, they're not exactly the same. Okay. Like here, we had the square root of 6 and square root of 6. So we can combine those two, put them down there. Like this one. We had the square root of 2 and the square root of 2. We were able to combine the 6 and 3, and we got our 9. But since they are not the same radical, boom, that's your answer. That's it. Yes. Right now, we're adding and subtracting. Okay? I'm just about to introduce multiplication. Yep. So you can leave it just like that, Allison. I know. It looks gross. It just looks unkept, but that's it. Yeah. All right. Okay. Good. Good. Not a problem. Thank you. Appreciate it. All right. So that's adding and subtracting. Okay, so the key takeaway from adding and subtracting, you need to have the same radicals. If you have the same radicals, you can add or subtract the coefficients, depending on what signage they're giving you. All right? And then you bring it down. It's like a funnel. Anytime you're solving, you're just bringing it down till you get to the lowest expression. If it's an equation, it'll be like an x equal or y equals a single answer. All right? That's what we're doing. That's the whole goal of it. Now, I'm going to flip to the other side of my handy dandy notebook. All right. If you like my notebook and how it's somewhat designed, let me unshrink this. I actually created this notebook. All right. So you're probably seeing my factor sheet. Okay. So I have factors from 1 to 200. And then I have a whole bunch of other things like reviews and reminders to help you with your math. This book is really designed for 7th grade and up to adults. Anyone that's taking all those classes. So Pythagorean theorem, we have the SOHCAHTOA. Some people, when they get into the pre-calculus, they have all the trig identities. Then we also have volume and surface area. I think a lot of students just finished up on that lesson. And then the area, the sector, and the arc length. And also, I think a lot of people are slowly getting into, if I'm not mistaken, looking at the unit circle. Okay? And then also I have a couple brain break activities. Everybody needs a little brain break. But it just gives you a place to organize it. If you ever... my handy dandy notebook. So if you do want to purchase your own, I do have them for sale. You just have to click the link in my profile. Go to my website, ACG Math Tutoring, and just look up the Ultimate Math Notebook. Yeah, I was being a little facetious with the name, but here we are. Because I don't see anyone else having notebooks like this with the resources. I see Cornell notes. I see, grid paper, but I have yet to see one that gives me resources that I can use in my class today, right? It's always multiplication charts, which the kids cannot, the young people cannot understand. I don't know why, but here we are, okay? So if you're interested, it is purchased on Amazon. It's up to you. Now, back to our regular scheduled program. So we're going to multiply these radicals. Let me just put it up on here. All right, so here's a couple things I want to go through. So in order for you to do multiplication, you can multiply radical with radical and whole number with whole number. All right. So if I have something, I'm going to write this multiple ways. So if I have 2 times 5, I know I'm insulting your intelligence, but there's a method to my madness, okay? What's 2 times 5? Put it in the chat. Hey, California Living, how are you? All right. Yes. Good. I love it. Yes, good. Amy, welcome in. Yes, CeeLo. Yes, 10. Good. So, we got 10. Now, what do you think is 2 times the square root of 5 equals? If you could take a guess, what do we think 2 times the square root of 5, what do you think that will equal? Mi gente, good guess. Nicole, good guess. But what's different between these two? What's different? Okay, everything is saying 5. Shiloh saying 0. Okay, the radical, that's what's different. Katie is saying 2 root 5. That's saying 5, it's simplified, okay? 2 square root of 5. So remember, the first one, we were able to multiply a whole number with a whole number, and we got a whole number. Here, we got 2 separate worlds. We have a whole number and a square root and a radical. So they can get close together, but they can't be together. You know what I'm saying? I feel like I'm talking like a teenager right now. Like they're going out, but they ain't going out. So you got like 2 square root of 5. Right? So they can get as close as they can to each other, but they can't mix and blend. Oh, it's the Ultimate Math Notebook. If you just go to my profile, you go to my website, there's a link that says Ultimate Math Notebook, and it'll take you straight there. So you don't have to go running all over the place. All right, thank you. All right, so what happens if I do this? I'm going to take it off to the side here. What happens if I do this? So I'm saying 2 square root of 3 times 5. Think about what we just said. What would this equal? You're welcome. So Katie's saying 10 root 3. Drake is saying 10 square root 3. Nicole is saying 2 square root of 15. Okay, same rules apply. I'm seeing 10 square root 3, 2 root 15, 10 square root 3. Stop napping and start tapping. Look at you. Thank you, California. All right. Think about it. Although in between the 2 and the square root of 3. Okay, good. I'm seeing some 10 square root 3, 10 root 3, 10 root 3. Awesome. This is all multiplication. It's really 2 times the square root of 3 times 5. Now, the 5 is not under a square root. So I can only multiply whole numbers with whole numbers. I can multiply whole numbers with whole numbers. So when I multiply the 2 and the 5, I do get 10. And then I just bring over the square root of 3. Okay? All right? So you can only multiply whole numbers with whole numbers. This 5 is not under a square root. The only thing that's under a square root is the 3. So that means I'm multiplying the 2 whole numbers, which is the 2 and the 5. That's where the 10 came from. And the square root of 3 comes over. Okay. You okay, Nicole? So the cover? Sure. There's 3 covers. The insides are all the same. Wow. Very zoomed in. So you have this cover, or you can have this cover, and there's another one that's like really light and pink and stuff. Okay, so any one of those 3 will work. They'll have the same interior. I just decided to do 3 different exteriors. Okay. Yeah, I believe you're trying. I got you. All right, I got you. Because remember, this is probably like the very first time that you've ever seen this. It's almost like you're asking for a baby to be just born to sing and dance as soon as it comes out the womb. Like, no. No. The fact that a couple days later it's like, oh, look, a thumb. And, you know. Okay. So, again, slow and steady. Okay. Just try to remember the rule. All right. So, let's try this one. I know I'm doing a whole lot of 2s. But let's try this one. So, if I have 2 to the square root of 3 times square root of 5. What would that give me? Okay, what would this give me? 2 to the square root of 3 times the square root of 5. Okay, so MGG says 2 square root of 15. Is it Matoya? A 2 square root of 15. Everything's 2 root 15. Okay, Mahente, that's fine. Okay, Cookie, 2 root 15. Mystical. Math. Danger. Yikes. It's okay. So, multiply 2 root 3 root 5. Okay. I see this. I run the other way. It's okay. You don't even have to run. You're in your own house. Everybody's like, what the hell is she running for? I don't know. You can always scroll. But there's no escaping math. It will hunt you down. But, all right, we don't have Squid Games here. It's okay. It's okay. All right. So, think about the rule. Okay? You multiply whole numbers with whole numbers, radicals with radicals. So we only have this one whole number on the outside. So that stays outside. And then we multiply the two radicals. 3 times 5 gives me 15. So my answer is going to be 2 square root of 15. Okay. Outside with outside. Inside with inside. Yes. See, a lot of people kind of like tried to use radicals like a house. Okay. You can multiply the stuff that's inside the house and then multiply only the stuff that's outside the house. Okay. I thought they have to be like numbers. Yes, when you're adding and subtracting, Deborah. When they're adding and subtracting, they have to be like numbers. But when it comes to multiplication, it's free game. As long as you're underneath the radical, you guys can multiply together. If you're outside of the radical, you guys can multiply together. Okay? But a whole number cannot multiply with a radical. Two separate worlds. Okay? Good. I know, there's a lot of rules. You know? Hell, it's almost like dating me. There's a lot of rules. There's just so many rules. When you think you understand me, no. I'm a Libra, so, you know, it's all kinds of cray-cray. All right? So, it's a lot of rules. It's a lot of rules. All right? Let's try one more like this, and then we're going to start stepping up a little bit. So what happens if we have 2 square root of 3 times 4 square root of 5? She's like, ooh, think about the rules. Right? Definitely, you gotta stay on your toes, man. Gotta stay on your toes. Took me a long time to figure that out about myself, but here we are. You thought you were just coming here just to get a little bit of math. That's all. Nope. All right, so let's see what we have. So MJG, we got 8 square root of 15. Ope Montoya, we got 8 square root of 15. Cookie, we have 8 square root of 15. Nicole has 8 square root of 15. There we go. 8 square root of 15. Nice, man. Okay, so we got 6 square root of 15. Make sure you're multiplying the Deborah for the 2 and the 4. Okay, make sure you're multiplying. And then we have a 2 the square root of 15. Same thing, AMD. Make sure you're multiplying those two. Okay. All right. Anything else? Okay. There we go. All right, there we go. Students need you in the classroom. I know, but guess what? They can't have me. They had me for 22 years, but they didn't treat me right, so here I am. Flicking the hair on one side. Okay, I'm seeing a love of them. I don't want to get wrong, but please put the links below. Okay. Okay. All right. Oh, for the books? I think that's what you're saying? Okay. All right. I got you. All right. So here we go. We're going to multiply whole number with whole number. So when I do that, 2 times 4, that gives me 8. And now we're going to multiply radical with radical. So we have the square root of 15. So this is our answer. 8 the square root of 15. And I know for certain someone at one point saw the square root of 15 and they're like, oh, I can break that down. And then you're like, oh, wait, that gives me a 5 and a 3, so I can't break that down. I know. All right. Yes, bless. I will do that for you. I will do that for you. Okay. All right. So let's step it up a little bit. So those are basically when you're doing multiplying radicals, that's the only rule. Multiply whole numbers with whole numbers and radicals with radicals. But there are going to be times that you're going to need to break down, just like how we did, like this square root of 54, we broke that down. That square root of 8, we broke that down. That square root of 24, we broke that down. Same thing is happening, but through multiplication. Let me demonstrate. So we're going to have our example. We have our negative square root of 5 times square root of 20. Probably like, what? All right. When you come across a situation like this, yes, they're both radicals. And you're probably saying, hey, I can probably break that down. Let me multiply them since they're both radicals. Okay. So I'm going to show you one way of doing it, and I'm going to show you another way of doing it. And you get to pick which way works for you. Because remember, everyone doesn't learn exactly the same. Okay? So if I want to multiply first, I think the orange is kind of working for us a little bit. So I'm going to do multiply first. Okay? So if I multiply, 5 times 20 gives me what? Hey, is that Ruth? All right. It's okay, Cookie. All right, so I'm seeing a 100, 100. Hello, Elizabeth. Welcome in. 100. Cookie, 100. All right, good. So they're still underneath a square root. So it's going to be a square root of 100. And there is still a negative outside of that square root. Are we okay with me so far? Thumbs up. It's like thumbs up or tap the screen for some hearts. I just want to know, are you okay? You can use a thumbs up. You can use a yes. You can be like, hell yeah, whatever you want to do. Whatever it is, give me some kind of signal. There you go. I love it. I love it. Good. Not Ken. Good job. All right. All right. Robin. Yes. Beautiful. Thank you. All right. So now, the square root of 100. So let me go to the back of my handy dandy factor sheet. So 100, wow. I know, all this turning around, I'm so sorry. So 100 is in blue. So that's telling me 100 is a perfect square. Here we go, square root. Because I see 10, 10, that means two of the same numbers. So the square root of 100 is actually going to be 10. So when I come back here, I got my square root of 100 gives me 10. Is that my final answer? Okay, see a whole bunch of 10s, which is awesome. Yes. All right. Okay, there we go. Oh, here's a name I haven't seen in a while. All right, so it's not because we have this negative that's in front of that square root. We need to drop that negative down. So it's not going to be a positive 10. it's going to be a negative 10. Okay? So what we did was we multiplied the radicals together, got the 100, brought down the negative, because remember, a negative times a positive gives me a negative. When the signs are opposite, when you're multiplying or dividing, your answer is always negative. Okay? I'll talk to you about later on about negatives underneath the square roots. That's coming. It's not here. Okay? It's coming, but not yet. All right? So the only thing you had to remember was to bring that negative down for your final answer. Okay? All right. So now, that was multiplying first. Like I said, there's two ways, and you figure out which way you feel comfortable with. The other one is simplifying first. Okay? So, what I mean by that, just like I think it was T. South would say, look at the highest one. Can we break down the square root of 20? Well, yes, we can. So if I come here, I'm looking at 20. 20, I have factors of 1 and 20, 2 and 10, 4 and 5. 4 and 5 is that perfect prime combination. So 4 is my perfect, 5 is my prime. So we come back here, and I'm just going to rewrite the problem. So it's going to be negative square root of 5 times the square root of 4 times the square root of 5. This part came from the square root of 20. Okay? Good. Hey, Janice. Okay. All right. So now, if we notice, we have the square root of 4. Square root of 4 is a 2. Now, we have the square root of 5 times the square root of 5. They can be multiplied. What's 5 times 5? Yeah, we're about to multiply now. What's 5 times 5? 25, right? Yeah, good, awesome. I know, I'm insulting your intelligence. Just work with me. There's a method to this madness. So that would give me the square root of 25. What do we know about the square root of 25? We're going to take care of the negative in a second. Just in a moment. Because right now, we did 5 times 5 gives me the square root of 25. Square root of 25, good. 5, 5, 5, 5, good. So the 5 is going to come down. And remember, all of this is multiplication, and then someone reminded me to also bring down the negative. It's a really long negative line, but here we go. Work with me. So Jan is very close. Not just 10, but yes, not Ken. Okay. Negative 5 times positive 2 gives me a negative 10. So you could simplify the numbers, get them to their simplest terms, and then multiply. So like I mentioned, there's two ways of doing it. Either you multiply them, then simplify, or you simplify, then you multiply. Okay. Yep, I almost forgot the negative 2 until someone mentioned it in public. Now, shortcut time. Remember this part where we had 2 of the same numbers underneath the square root? That's square root of 5 times the square root of 5. Notice we got an answer of 5 from it. Okay? Let me try this on you. If I say the square root of 3 times the square root of 3, that answer is going to be 3. If I say the square root of 144 times the square root of 144, what will be my answer? It will be good. It will be 144, 144, 144. Okay? Because I know, Nicole, you were right. Square root of 144 is 12. Square root of 144 is 12. 12 times 12 will give me 144. So here's a shortcut. You want to write it. Shortcut. When you are multiplying, and only when you're multiplying, when you are multiplying and you're multiplying the same radical with the same radicands, which is the numbers underneath the radical, your answer is always going to be what was underneath the radical. Every time. Like every time. Did I mention every time? Yeah, every time. All right. So even if you come across and you say, oh, square root of 4 times square root of 4, you don't have to go 4 times 4. That will give me 16. And then the square root of 16 will give me 4. Shorten it up. Because remember, it'll be kind of nice to have these, to remember those. Because when you take these timed assessments, I'm not saying you have to answer the question in like less than like 45 seconds. Most of the assessments, GED, Accuplacer gives you more time. ASVAT, they usually give you roughly around 2 minutes and 15 seconds per question. And let me tell you, you're going to see some questions that's going to be really easy for you to complete, and you'll get it done in maybe like 15 seconds, which is great. You get your answer, you mark it, you move on. But then that extra time that you didn't spend on that question could go towards like harder questions that you want to take some time to wrap your head around. Okay? So especially GED, because I hate when they have the screen and on the, I think it's on the right hand side, they have the timer and everyone focuses on that timer. Guess what? No matter what you do in life, you can sit still, but time's going to keep going. So don't freak out. All the time's moving. It's supposed to move. Okay? You just focus on your task at hand. There's going to be some things you're going to know just like that, and there's going to be some things you're going to need some extra time on. Okay? So use that as a strategy. That's why I always feel like when you try to learn from other people, when it comes to these type of assessments, you're trying to learn the stuff. Once you're trying to get your GED and all that, you're just trying to pass the test. They don't care what's on your scrap paper. Okay? They really don't care. All right. So, enough preaching. Here goes next one. I know. Sometimes I get on my little soapbox because I want everyone to do so well. And sometimes they self-sabotage and it makes me crazy. All right, I'm obsessed with 5s tonight too. Okay. Yes, the square root will definitely equal itself. So we got the square root of 15 times 3, the square root of 5. Okay, the square root of 15 times 3, the square root of 5. You pick and choose which way of these you liked. Did you like the multiplying first and then simplify? Or did you like to simplify and then multiply? Up to you. Give it like 40 seconds and then we're putting our answers up. So don't put your answer up yet. You can type it in, but don't hit send. Okay? Whichever hits your boat, Sophie. Whichever hits you. Whatever is like, yes, I like that better. Do it. Okay? But don't hit send on your answer just yet. I want to give everyone the opportunity to break down the answers, not break down mentally. Okay? Sometimes I got to clarify that. Hey, Lynn. It's up to you. It really is up to you. That's why I give people a choice. Makes my brain hurt. It's okay. It's stimulating your mind. It's stimulating the mind. Okay. So every situation is different. That might be too late. Okay. Go ahead and show your answers. What did you guys get? Okay. Ooh. I see 3, the root 75. That's fun. Okay, bless. Okay, you can copy and maybe not. All right, it won't let me copy and paste the link for Amazon for some reason. Let me see. Let me see if it'll do it this way. Very close. Very, 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 very close. Okay. Give that one a try. Copy and paste that link. And that should take you directly to my page on Amazon. So already available on TikTok Shop. It's not. I'm still trying to figure out TikTok Shop. Everyone thinks it's super, super easy. But since I am a service and I don't want to buy all the books, I really want you to get it directly from a publisher because I don't want to have all these books here and then I'm going to have to charge you like a mint for me to ship it to you. That's the killer. I don't know how people are doing shipping, so I'm trying to figure it out. Would it be 3 times the square root of 75? That I keep seeing. Okay, let's take a look. So, I agree that it has multiplied the radical with the radical, and we bring down the 3, and we have that square root of 75. Now, Square root of 75. 75, let's take a look at their numbers. Oops. Sorry, I'm trying to hold everything up. It's like me in a girdle. Anyway, so we got 1 and 75, 3 and 25, and 5 and 15. We can break down that square root of 75. If we look at 25 and 3, 25 is perfect, 3 is prime. So if we go, we can break down the square root of 75 into two radicals. We got 25, which is my perfect, and 3, which is my prime. Spotify? Spotify sells books? Yeah. Don't worry. I'm researching as we speak. Just have to make sure all my financial stuff. Okay. Oh, Shopify. Okay. I was like, Spotify? I was like, wait, hold on. Did I miss a memo? Because everybody's merging with everybody. So, you know what? I can't keep up lately. You know, 1 minute it's this and now it's named that and everybody's merged together. It's just too much. Grade level with this, it's like Algebra 1. I think in an advanced algebra, yeah, I would say Algebra 1, to be honest with you. Yes, you always should see if you can break it down, especially the radicals. So now that you see this, what would my final answer be? Let me give you an opportunity. Okay, so girl mom saying 15 times the square root of 3. Okay, my gente saying 3 the square root of 15. Flip it around. My gente, flip it around. Okay, the square root of 25 is 5. Yes, Sarah, good. So we're bringing down that square root of 3. Bringing down this 3. Okay. Oop. Let me zoom so people can see. All right. So we see it now. Square root of 25 is 5. That was a perfect square root. Okay, Sarah kind of helped us out a little bit. So now we still have this 3, that whole number of 3 that came with the original problem. So we are multiplying whole numbers with whole numbers. So 3 times 5, that gives us our 15. And we bring down the square root of 3. Okay, there we go. So 15 square root of 3, 15 square root of 3. There we go. Okay, makes sense? All right. So we're taking a little bit of always looking to simplify. Okay. When you're dealing with math, you're always, like if you're trying to get to an argument, let me put a major example. So you and your partner is arguing, right? And you're trying to get all the bits and pieces of information. Maybe this is why I'm not married anymore. I'm like, wait, hold on. So let me see if this makes sense. So you went to her house to pick her up, to drive her a block away from her own house, just so you can drop off a flash drive that you knew that you can give her the next day. Okay, all right. Let me see if I understand, right? And you playing detective, like you're taking every element of everything. I'm like, well, hold on. But last week, you said, and I quote, and you start whipping out receipts and stuff. And this is the same thing that you're basically doing. You're taking a lot of bits and pieces of previously learned concepts, and you're always trying to bring it down. You're always trying to simplify till we get down to either one answer or what's called an expression. All right. So we're either going to get it down to a term or to an expression. Yeah, right? The math never maths. And you're just like, okay. You're like, what? Don't you trust me? Hell no. And I don't trust you with her. So, yeah. Aren't you glad you're learning so much about me? You're probably like, this chick is crazy. All right. But everything in life is just like relationships. And that's the one thing that I loved doing when I was in the classroom. I will always give examples that made sense to my students. You could put anything relating to food, anything. It doesn't even matter. If it has food associated with it, that's going to work great for your classroom. Anything with food, relationships, like when I say like girlfriend, boyfriend, best friends, any kind of relationship, any kind of ship whatsoever. Whoop, got a little crazy. And then social media. Who's beefing with who? Who's fighting with who? It doesn't matter. It works. And the kids will still remember it. And that's what cracks me up. So let's try this. But why do people think that that same logic stops when we get older? No, it still works. Put anything with food, we can do it. Can we do algebra? Yes, we can. So, square root of 9 times square root of 3. Yep, anybody can do algebra. Got a little too sensitive to you, Ken? just kind of pushed you over the edge there, buddy. All right. Okay. Take a look. Okay, so I got a square root of 27. I got a 27. I have a 3 with a question mark. Hey, Queen. How are you? What did you say? What, about the mathing? Oh. Oh, okay. Nicole has 3. I want to say 3 root 3. Okay, I just bought your books. Oh, thank you. I appreciate that. Yep, we got Bog. Hey, Bog. We got through root 3. Yes. I was texting. Oh, okay. No problem. We're just breaking this down. 3 root of 3. Yes. Please, I want the books. Okay. All right. So if you placed your order for Amazon, Amazon's going to send you the books. Okay. Is that what you're asking for? Because I did put the link in the chat. Do you need it again? Wait, square root of 9. Yes. What about the square root of 9? Danielle, what did you get for an answer? So you're saying 9. Okay, 3 root of 3. Oh, no, I was just solving with this. Janice, that's what I was doing. Just solving with this. Square root of 9 times square root of 3. Okay, so you got 3 root of 3. We got 3. We got the square root of 9. We got 3 root of 3 for, hey, Jeanette, how are you? All right, so let's take a look. Remember, we had a choice. Either we're going to multiply first or simplify first. So in this case, we could do one of two ways. Okay, of course, I'm going to take the long way first, just so it'll be a teaching moment. If I want to multiply first, 9 times 3 will give me 27. Square root of 27 gives me square root of 9 times square root of 3. Didn't I just go back into Twilight Zone? I went right back to the original. Square root of 9 gives me 3. Square root of 3 comes down. So that's multiplying first, then simplifying. Or we can do this. We have the square root of 9. That gives me 3. And then we have the square root of 3. That just comes down. Either way, you're going to get the same answer. Okay? It all depends on what it is. For me, I'm lazy. I always like to say, all right, is there something I can break down? Is there anything that's perfect? Oh, 9's perfect. Oh, that's a 3. Oh, that's square root of 3. That's prime. Boom. Done. Move on. Okay? Good. Exactly. Bam. Let's get right to it. If your professor wants to simplify more, your professor is on crack, because there isn't anything else that we're doing. Because I've been like, seriously, dude, get a life. No, we're not going to do any more. Okay? No. So that is as far as you can go. Unless they want it rounded to a certain decimal point, that's something different. But majority of the time when they're saying simplify, that's it, baby girl, right there. Okay? Yes. Always be on the lookout for the perfect square. That will make your life so much easier. Okay? Yes, so Danielle, we're not in that. Because imaginary numbers, that's when the negative is underneath the radical. Okay, so we're not doing that just yet. Okay, that's the only time you're doing that imaginary number. Okay. How often? I try to be here every day, at least once a day. I can't do multiples because I got clients. But Wednesdays is usually at 9:45 because I finish my evenings pretty late. And today is Thursday, same thing. But sometimes I'll get cancellations, so I'll just come on early. So I try to shoot between like 8:30 or 9:30 is generally when I do it. Okay. Am I taking clients? Of course. Like 8th graders? Of course. Yep. I have clients all over the place. I have some in California, Texas, Alaska, Florida, Mississippi, North Carolina, South Carolina, Georgia, Maryland, obviously. Where are we? I have one in Vermont, probably going to come back. I had one in Massachusetts, probably going to come back soon because finals are coming up. Yeah, so all over. Yep. Just anything, just DM me. Yeah, just message me. That whole subscription thing should be removed. Do I do geometry? I do. Am I in love with geometry? No, but do I know how to break it down? Yes. It's the proofing that usually gets the students. All right. Yes, I'm all over the place. I did have a student in Nairobi, Kenya, and one in Cairo, Egypt, and they passed their GEDs, and now they're doing fabulous. they're actually thinking about moving here in the States. I'm like, what? All right. Okay. All right, let's try 2 more, and then we're going to wrap up, okay? Now, while I'm setting this up, I'm kind of thinking ahead to, like, the summer, because we all know the summer is going to be right around the corner. I would love to know, and as truthful as you can tell me, would anyone be interested in taking a course designed and, instructed by me to help either with the GED or Accuplacer or just basically hitting on all the algebra components? And I was thinking about starting it in June, going all the way to I want to say early September. Okay? Constantly seeing each other basically 4 times a week. We'll have the 1 week off for 4th of July, and then the 1 week off before the kids start school, because we all know parents usually got to go shopping for stuff. Does that sound like a good idea? Do you help with matrices? Yes, I actually did matrices last night. I was doing multiplication and how to solve a system of equations through matrices. We were doing that last night. You might be able to find that on my YouTube channel. Where's my sheet? Where is my paper? Because if you look, you cannot see that. Okay, if you want to, you can subscribe to my YouTube channel. So Audrey Codner, ACG Math Tutoring. I have a section that says TikTok Lives on there. I put my replays of all my TikToks on there. So as soon as I'm done with this, I sit here for an hour and a half, almost 2 hours, downloading it, and then have to wait another half an hour plus to upload it on YouTube. But I do it for you, because I do. So you can actually go there if you do need some more assistance. Okay. All right. So I'm seeing some answers. I'm seeing -4 square root of 80. Okay, not Ken saying -20. Okay. The parabola is haunting. Oh, it's not haunting, is it? Yeah, I know. It's and especially at the pace that you're learning it, it doesn't help at all. Okay. So now I have -4, the root of 80. Okay, now for those that are saying root of 80, the square root of 80 can be broken down. Square root of 80 can be broken down. Question mark? Or 40? No? What do you mean no? Cookie, what do you mean no? Square root of 80 can be broken down. Yes. Okay. I'm seeing a no. I'm seeing a yes. Are we okay? Okay. Would you like for me to go over this now? Or are there any more answers? Okay. All right. So -4 square root of 20. Okay. All right. So we're right kind of there. Okay. So again, you got two choices. Either we multiply or we simplify. I know if I multiply the 8 and the 10, I'm going to get a larger number. But both of them are even. Okay? So if I have my 80, slide over, we got our 80. So we got 1 and 80, 2 and 40, 4 and 20, 5, 16, and 8 and 10. Now, if you try to keep it with the 8 and 10, you can still break them down. But your perfect prime combination is going to be 16 and 5. Okay, I'm going to show you why in a moment. So you were right with the negative 40, square root of 80. But the square root of 80 can be 16 and the square root of 5. And I'm bringing down the negative 4. So now I have negative 4 times the square root of 16, which is 4. Bring down the square root of 5. So now, negative 4 times 4 gives me negative 16. And I brought down the square root of 5. Okay. So negative 16. Hey, Kim. All right. Okay. So if you tried, let me show different ways that we can get the same answer. So I think some people had negative 4, square root of 8, square root of 10. And I think when they got the square root of 80, negative 4, they tried to break down the 80 with 4 and 20. Okay, this can work. But that square root of 20, that can be broken down again. Square root of 20 is 4 and 5. So it looks like this. And I bring down my negative 4. So I got negative 4 times square root of 4 times square root of 4 times square root of 5. Remember what we said about square root of 4 times square root of 4. What would that give me? Okay. All right. It will give me 4, right? I know 4 times 4 gives me 16, but then the square root of 16 is going to give me 4. Remember our little shortcut. Okay? When it's the same numbers being multiplied, your answer is just going to be that number without the radical. Okay? That's okay. It's a habit. It's a habit. So now we bring down our negative 4 times this 4 times the square root of 5. Now we multiply whole number with whole number. Negative 4 times 4 gives me a negative 16, and then I bring down the square root of 5. So you could use 4 and 20, but you're going to have to break down that 20. Okay? I try to go for the largest. Okay? If I have 80, I went with the largest perfect I can fit. And I just did trial and error, or you know your multiplication signs. Now, you could also, let's see if I can put it underneath. You could have done negative 4 square root of 8, square root of 10. You could have simplified this. So for the square root of 8, we got 4 and 2. Bring down the negative 4. For the 10, I know it's one of those perfect or one of those prime, special prime radicals. But I notice here, I'm able to get 2 of the same radicals. And we know that the square root of 2 times the square root of 2, that's going to give me an answer of 2. So we have negative 4 times 2. But then we have the square root of 4. That square root of 4 is also a 2. And then what remains behind is a 5. So now you got to multiply these 3 numbers. Negative 4 times 2 gives me a negative 8. Negative 8 times 2 gives me negative 16. And I bring down the square root of 5. So we had 3 ways. Okay, we did the multiplying and simplifying with the highest perfect. We did multiply and simplify with, I want to say, possibly the lowest perfect, but we still had to break down that square root of 20. Then we could have just simplified and then we multiplied. So we broke down the square root of 8, which is 4 and 2, break down the square root of 10, which is 5 and 2, pull out your whole numbers, multiply them together, and then drop your radical. Okay? Pairs, yes. All right. Okay. Troopers holding on. I know. It was a lot. But that's basically adding, subtracting, and multiplying radicals. Okay, that's all I have. Any questions? The way you just did, but I missed one of the 2's. Yes. Okay. Thank you for the tapping. Yeah. So again, if you want me to put, because this is the stuff that if I'm going to do it, I'm a type of person that when someone says, yes, do that, I'm going to do it. Like, you may not hear from me for like a week because I'm putting things together. But if you're saying, yes, that would be helpful. Oh my gosh, this would be wonderful. And of course, for me, I'm going to be truthful. It's going to be a small fee, but it's going to be a small fee. Like when I say small, like it's not going to have 3 digits in there. It's not going to be past 40. Okay. It's going to be down there. But at the same time, we need to take a look at what it is, what you want to achieve. Because I know there's a lot of free services out there, and I always tell people, I'm like, well, how's that working for you? And they're like, it's not. And I'm like, there you go. Like, everyone wants free services, and I'm not sure about you, but I know in Maryland, our federal government shut down a lot of the free services in Baltimore City and Baltimore, and some in Baltimore County as well. So, yeah. I don't know what service nowadays is free, to be honest with you. But I'm here to try to break down concepts as best as I can. What is this called? This is adding, subtracting, and multiplying radicals. I'm going to try the test next month. See what happens if it works out. Okay. I will not. I'll sign up. Okay. Perfect. Okay, not a problem. I'm always here to kind of help. Well, I don't want to say I'm always here, but I tried to be here to help. I want to break this whole thing called math phobia. Like, oh, I can't do math. I'm like, no, you just had a horrible experience and you don't want to repeat it. You didn't have a teacher that was willing to repeat and to answer questions. And plus, it's kind of tough to do that when you're in a classroom of 35, sometimes 40 students, and everybody wants individual attention. So it's almost like you can't get individual attention. It's almost like you get no attention. So I get it. Okay, good. Give it a try. Go through the practice problems. If you get stuck on them, please do not hesitate. Let's set something up. Let's have those discussions. Because as you can probably tell, this is book 3, and I started doing lives February 6th. And, here's, matrix multiplication. Oops, got a little crazy. Okay, we got matrices, adding, subtracting matrices, and also multiplying with a scalar, system of equations and inequalities. We did that real quick the other day. We did a little bit of finding the trig functions using a point. That's more advanced stuff. That was just giggles. But, distance, rate, and time word problems, they're definitely on the GED, AccuPlacer, SAT, ACT. Any kind of state assessment, they always have at least 1 or 2 of these type of problems. So memorize this bad boy right there. So then simplifying radicals, we did that the other day. So it's like, and then we worked on fractions. We worked on Pythagorean theorem, parallel and perpendicular lines, writing equation of a line, reviewing central angles, graphing linear equations. So a lot of these things we actually did together. Now, I am trying, didn't know it was going to be this difficult to put my notes up, and I'm trying to sell my actual notes so you can download them. But what I'm trying to do is connect them to the video. So you're not like, probability of simple events, and then you go to my YouTube channel and you're too busy searching for it. I'm trying to put a QR code, which that's easy enough to do, but trying to find all my videos, because some of my videos, I was like, wait, why is that not on my YouTube channel? And I uploaded so many videos. Maybe because a lot of them didn't get uploaded. Discovered that today. Yeah, I'm tired. So I'm trying to do a QR code or a link that you can click on or take your phone to scan, so it takes you directly to that live, so you don't have to go searching for it. That's what's taking me so long, okay? So it's not like I'm dodging it, but because there's some people that says, I really want to have copies of your notes. And I'm like, all right, cool. Because I tried to keep it nice and neat. I'm always like that. And also color coordinating, so you'll actually have like all the full page stuff. All right. So that is it for me. If you guys can do me a favor, subscribe to my YouTube channel. Follow me here. I think a lot of you guys are following me here, which is awesome. Also, if you want to, do a Google review for me, because this is like tutoring. So I really want to get at least like 100 reviews. This helps a lot of other people, for them to pay me. Because if I try to do things through TikTok, it's like, all right, they're taking 50% right out the cup. But if anything, take a look at that. My live schedule, it's all over the place. But I'll be here tomorrow at 1 p.m. because my Fridays, I usually do it during the days. I think we're going to be doing dividing. So if you can't meet me, go to my YouTube channel to watch the reviews or to watch the replay, and you can take it from there. I think some people did mention a couple of these. So if you're going into nursing and you need another person to follow, you can follow a Blessed RN. She's amazing with breaking down concepts on how to get your dosage without doing a whole lot of math. We also have, if someone for T's, ASVAT, GED, and you need someone during the day instead of the evening, you can go to my friend Evelyn on Impact Math 19. She usually goes on every day at 1 p.m. Central Time. So if you're on the East Coast like I am, that will be 2 p.m. And then you have a chemistry tutor. That's what I forgot to do. She goes on at 10 a.m. Eastern Standard Time. But I think she's also Central Time as well. But she's on at 10 a.m. And then if you want, my friend Lynette, she actually teaches how to do math, adding, subtracting, multiplying, dividing, using the abacus. This is going to be something like she's starting to teach adults how to use the abacus, and they can teach their kids how to count, how to add, how to subtract. So we're slowly but surely trying to break this whole thing called mathphobia, one step at a time. So definitely take a look at her. She's probably going to be going on live maybe in a few minutes. But that's about it. All right. Yes, Cookie, thank you. Thank you for coming in. Have a good night. Thank you, Girl Mom, for stopping in. Thank you for the follows. Thank you for the likes. Thank you for being you, just wanting to do math. Like, it's 11:48 p.m. my time. Like, why are we up doing math? But we are, right? It is fun. Like, just trying to get that brain stimulated. There's always so much stuff that's like trying to kill our brain cells. Like, let's do a little bit of math. Like, let's touch on one of those barriers in our lives and actually feel conquered. It's such a good feeling. All right. So thank you, Deborah. Thank you for stopping in. Yes, have a good night. I will probably see you guys. Yes, 15K. Thank you. Pog, you're always that person like, hey guys, go ahead, tap away, let's go. You're always like my great supporter, man. I appreciate you. I appreciate you, my love. All right. So we're all going to go to bed, separate beds. Let's not be crazy. And I will see most of you tomorrow at 1 p.m. Eastern Standard Time. And Saturday and my Sundays are like a wild card, but it might be late on Sunday. But Saturday, it might be late as well. It might be at 8:30 for both of those days. Because I'm starting to get students coming back. They're getting ready for their finals. Alrighty? Okay, have a lovely night, and I will see you guys tomorrow. Thank you again for your support and love. I appreciate you. Keep being your awesome selves. All right, bye now.